The next thing we need to talk about is the zero exponent property. Any non-zero number raised to the 0 power is equal to 1. The only thing that this doesn't apply to is if you'd have 0 raised to the 0 power, that is still 0. Okay? However, actually, I'm not entirely sure. This is either 0 or you'd get an error. Off the top of my head, I'm not sure what you get. I just know, I'm pretty sure it's 0, but you could get an error. Not entirely sure on that. However, anything else, whether it's 10 billion or negative 3,720x, anything raised to the 0 power besides 0 is going to be 1. So 15 raised to the 0 is 1. B over C, all raised to 0, it's 1. 2 over 7th raised to the 0, it's 1. It does not matter what you have, as long as it's raised to the 0 power, it's always going to be 1. So if we look at our third example, this looks pretty complicated inside parentheses. We got 4n squared q to the 5th r to the 2nd, all divided by 9n cubed q squared r. Looks like it's going to be hard, but notice everything's raised to the 0 power. If something's raised to the 0 power, it's just 1. That problem becomes really easy. Everything's raised to the 0 power. I don't care what it is, as long as it's not 0 raised to the 0 power, it's going to be 1. This second example, we've got x to the 5th, y to the 0 power, divided by x cubed. Well, we know y to the 0 power is just 1, so I've got x to the 5th times 1 over x cubed, which just gives me x to the 5th over x cubed. And I've got the same base. I'm dividing, which means I need to subtract my exponents. That's going to give me x raised to the 5 minus 3, and I get x squared. Anything raised to the 0 power is 1. It doesn't matter if it's something as easy as y raised to the 0 power or this whole mess raised to the 0 power. It's always going to give you 1.